Hello, good morning to everyone. We are starting this SANKALP classes specially for CET because we can help you a lot by giving proper guidance, by giving synopsis, explaining the concepts, and then answering some multiple choice questions with you. Later on, you also can solve some multiple choice questions by yourself. If you have any doubts, you can get it cleared, and in this way, you will get lot of help from our Sankalp, and that too at low cost. You have to utilize this to the maximum extent so that you can do your CET exams well and go through the exam. So hoping best of luck to all of you. We will start our first math class. In maths, you have many chapters combined first year and second year. So one by one, we will cover all the chapters, all the topics. But what I hope is you have to listen carefully in the class, take down the notes, listen to the problems when I'm solving, and then practice. You have to solve the problems by yourself, and then definitely you will get a good score in the exam. So today we are going to start with the chapter Sets and Relations. In this, in the beginning, I will give you some important points. If you understand this, you are learning the concept, and then most of the problems you will be able to do by yourself. So let us take first the definitions of a few things. The first one is set. What is a set? I can say a set is well-defined collection of objects. Now, what is well-defined? When I'm telling you about the objects, I must define it properly, and then I have to collect it. After collecting, I have to write the objects as a list inside the flower brackets. And then I have to name the set as with the capital letter A. All these things I have to do. For example, the very first thing is I want to tell about students. So I will take students. If I say good students, it is not well defined. Why it is not well defined? For me, I feel that one student is good because he is looking good. For another person, that student is good because he studies good. For a third person, that student is good because he is neatly dressed. So good students means there is not a particular definition. A good student may be looking good, may be studying good, may be dressing good. So it is not well defined. So first of all, when I talk about students, I have to tell properly what type of students I want. So I will say students in class 11 of your school. Now I have defined properly. Now I'll make a list of students who are in class 11 in your school. I'll write their names. For example, Ajay is there in your class. Beena is there in your class. I will make a list by separating the names with commas. Suppose Sally is there in your class, Diana is there in your class, then you have a girl called Fanny in your class, a boy called Ram in your class, a girl called Geeta in your class. So I will list the students like this, and then I will give a name to it. Capital S, capital A, capital B, any letter, capital letters you can use. And remember, you have to write within flower brackets. You have to use flower brackets to represent a set. And now I can say this is a set because it is well defined collection of objects. Like that, there are many more examples for sets, which we will study one by one. The next definition is, okay, I told you what is a set. How can you write a set? There are two methods to write a set. The first one is roster method or listing method. How to write this? In roster method or listing method, first of all, I'll give a name to the set A equal to, suppose I want to write the numbers 1, 2, 3, 4, 5. Like this, I will list the numbers inside flower brackets. And this is what is the roster method, listing method, writing the list of numbers by separating with commas inside the flower brackets. This is one method of writing a set. But the same set, if I want to write in another method, rule method or set builder method, then I have to give some rule. How can I give the rule? See the set A which I have written above. I will say 1 is an element, let it be X. 2 is another element, let it be X. 3 is the third element, let it be X. So all these are elements like X. So in general, I will write the set has X. All the elements I'm saying X, 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 X. But if I say X, 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 that is not enough. I have to give some rule. I have to explain you more. So if you see, 1 is a natural number, 2 is a natural number, 3 is a natural number. All these are natural numbers. So I will say X belongs to set of natural numbers. X I'm taking as natural numbers. But if I say natural numbers, that's not enough. Because when you start writing natural numbers, they never end. What are natural numbers? 1, 2, 3, 4, 5, 6, 7. They start from 1 and they never end. But I'm not taking all the natural numbers. I'm just taking 1, 2, 3, 4, 5. So how can I say that I'm taking only till 5? I have to say I will take X natural number less than 5 or equal to 5. That means I will take equal to 5. I will take less than 5. I'll take 4, 3, 2, 1. All these which are less than 5. But I will not take more than 5. This is how I will keep a rule. Now you can easily understand how to write the set A. You can understand looking at this rule. First of all, you will understand you have to write x's, many x's. What are these x's? They are natural numbers. Okay, natural numbers means 1, 2, 3, 4, 5, 6, 7, 8, 9. But then you will understand you have to write only natural numbers less than 5 or equal to 5. 1 is less than 5, starting with 1. 2 is less than 5. 3 is less than 5. 4 is less than 5. 5 equal to 5. In this way, I am writing the set which I told you about looking at the rule. So we can write the sets in two ways: roster method or listing method and rule method or set builder method. Now, writing the sets is not enough. We have to learn more specifically about sets. We have finite sets and infinite sets. Finite sets means these sets end after some time. Infinite sets means they will be never ending. For example, for finite set, I will say take x's such that X is a vowel in English alphabet. So I will name this set as A. I have to write X's such that they are vowels. In English, you know what are vowels? A is a vowel, E is a vowel, I is a vowel, O is a vowel, U is a vowel. That's it. I don't have any more. There are only 5 vowels. So these 5 vowels I'm listing looking at this rule. And this set has ended. It came to an end. That is why it is a finite set. For infinite set, already I gave you one example. What did I say for infinite set? One example. Take all x's such that x should be a natural number. Okay, now I will name the set as B. I'll use flower brackets and I have to write, looking at the rule, I have to write natural numbers. Natural numbers start with 1. So when you start with 1, you'll write 1, 2, 3, 4, 5. Like this, you will go on writing. This list will never end. And so you can put dots. Actually, you will not put too many dots like this. You have to write 1, 2, 3, 4, 5. You will put only 3 dots and then put the flower brackets. That means this will continue. The list will continue. It will never stop. So such kind of set is called infinite set. We will be dealing sometimes with finite set, sometimes with infinite set. Okay. The next you have to learn is about order of a finite set. What do you mean by order of a finite set? The number of elements. Order means number of elements in a set. How many things, how many objects, how many elements you are listing out. You have to count and then tell the order. But counting and telling the order is possible only in finite sets. If you have finite sets, they will end, and if they end, you can count and tell how many numbers are there. For example, I will give you a set A in which I will write some colors: red, blue, green, yellow, white, black, orange. I have listed them properly. So this is an element, red is an element, blue is an element, green is an element, yellow is an element, white is an element, black is an element, orange is an element. Total, how many elements are there? Count and write the order. 1, 2, 3, 4, 5, 6, 7. So order is 7. But this is not the way to write. 7 elements are there, order is 7. But you have to write n of A is 7. Write it properly. Number of elements in the set A is 7. Order of set A is 7. This is how you will write. I can write the order only for finite sets because we can count the elements only in finite sets. In infinite sets, we cannot count. For example, see on the top, this is an infinite set. I cannot count how many elements are there. 1, 2, 3, 4, 5. After that, many are there. I can't sit and count. That's why for infinite sets, we can't write the order. For finite sets, we can write the order. Let's go to the next. The next definition is null set or empty set. Suppose there is a set A in which there are no elements at all. Not even a single element is there. Such a set is called null set or empty set. Usually, null set is denoted by phi. So whenever I say phi, it means null set, empty set. We pronounce this as phi, P-H-I, phi. Phi is a Greek letter. We write it like this and we read it as P-H-I, phi. And it means flower brackets with nothing inside. Suppose if you write flower brackets and write 0, this is not a null set because there is 0 inside the set. Suppose if I write flower brackets and I put a point inside, this is not a null set because it is having point inside. Suppose if I put flower brackets and write a dash inside, it is not a null set. There shouldn't be anything inside the flower brackets, completely empty. Such a set is called null set or empty set. In null set, you cannot find any element. That is why order of phi set is 0. The number of elements in the null set is 0. That you can say 0. Or you can say n of 5 will be 0. Number of elements in the 5 set is 0. That we can see. The next is the definition of singleton set. The name itself will tell you single. If there is a set B in which there is only a single element, only one element, like only the number 5 is there. So, number of elements in the set B is 1. That means it is a singleton set. Suppose if I give you another set. In this, there is only one object like ball. So n of C, number of elements in the set C is 1. This is a singleton set. So a set in which there is one and only one element is called a singleton set. So with this, we will end this and we will start a few definitions in the next class.